Now, let's talk about the Docker Hub security scanning. So in addition to ensuring that the containers are properly configured from a security point of view, you should also ensure that all image layers are also free of known vulnerabilities. As you know, every image can create multiple containers, so even if you create containers from certain image and your container is secure, you might still have issues if there are some bugs into your image. And in order to inspect the images, you can use certain tools to scan that images in the Docker repositories. So here in this section, we'll review some tools such as Clair and Ensure to discover vulnerabilities in the container images by learning static analysis tools that analyze different layers that compose an image. The result of that will be the ability to be able to detect vulnerabilities in the container applications before uploading them to production. So let's talk about the Docker Hub repository and security scanning. So as you already know, the Docker Hub is a repository of Docker images in which any user can create an image and upload and share its images with the community. So there are two main types within that repository: official images that are normally maintained by official suppliers such as Apache, Nginx, MongoDB, Ubuntu, and so on. All the famous providers that are professional, and you heard about them. On the other hand, we can find images that are created from users. They've been customized and adapted to the specific needs for a specific project. So let's see how we can actually scan those images. So Docker security scanning is service available in the Docker private repositories, and it normally compares the container content which is scheduled by different layers of packages. We're inspecting those binary packages layer by layer against some list of common vulnerabilities and exposures database. So the scanning tools effectiveness depends on two main capabilities: the static analysis, depth and integrity, where the scanner discovers the image inner layers and the nature of those layers, and the vulnerability feeds quality. This indicates the coverage and how much the vulnerability list needs to be updated. So you should always bear in mind that in order to inspect our images for vulnerabilities, we can refer to those lists with known vulnerabilities and sort of automate them and use tools to check those lists and databases with vulnerabilities and see if our images is having those in automatic manner. So this is the whole idea of the image inspection. So let's see how the Docker security scanning process looks like. So the Docker security scanning is a process, and we can actually call it a tool that integrates directly with the official Docker Hub repository and allows us to automatically review images found in the public and in the private repositories. This service is available on Docker Hub public and private repositories in the Docker Cloud, and it is normally paid service in all cases with some free trials. So when a new image is uploaded to the Docker Hub or the Docker Cloud, it launches a process that extracts the image seeds and sends the image to the scanning service that scans the composite layers of packages, analyzing each of those layers with the CVE or the common vulnerabilities exposures. So finally, once the Docker analysis are completed, we're provided with a result with different vulnerabilities that are found and the level of criticality for each vulnerability. So the results report is generated, and there you'll be able to see how severe the issues in your system are. Normally, the level of criticality depends on the score assigned to the CVE code by the Common Vulnerability Score system. And I will show you right now the standard codes of that system. So firstly, you would have the high result, which means that the vulnerability is within the range of 8 and 10. Then you have the medium vulnerability, which has a score between 4 and 7.9. And finally is the lowest impact vulnerability, which is between 0 and 3.9. So this scan process can be easily integrated into containers integration and continuous delivery workflows, so that scanning can be started automatically every time the developer completes a new container. So today most of the DevOps teams only work on discovering new vulnerabilities with high criticality levels that are part of the CVE database. So the main problem here would be that the lower criticality problems could not even be discovered but can be reached by the potential attackers. So with the Docker ecosystem, the Docker file describes the dependencies and what will be installed in the container so that the application can run on it. So when running within a continuous integration environment, it will automatically generate and publish in the Docker registry, including the container software dependencies. So now once we stated the levels of criticality and some of the vulnerable components of Docker, let's now see some tools for vulnerability analysis in Docker. So in the recent days, the attackers are becoming more and more advanced. They have more complex techniques on finding vulnerabilities in the Docker containers and images. So when hackers try to find more sophisticated attacks methods and techniques, the cybersecurity analysts and the researchers should always work to prevent that attacks, and they're looking to prevent the resources in risk. So due to that, DevOps requires the establishment of functional image scanning and validation mechanisms in order to comprehensively protect the image creation and container creation process. So here are some recommendations to guarantee the control of the source code and the deployment of different environments. So to do that, we need to include tools to automate and organize the source code. And that's why the first rule is the source code control. The source code control should be a common practice in the DevOps security to ensure high quality while contributing with unit and integration testing. And you probably know the main tools for doing that. Those are, for example, GitHub, GitLab, or Bitbucket. Also, a project should always have CI/CD tools. This is because the development teams use construction tools that are essential part of their automated compilation process through the CI/CD tools, and the most famous ones are Bamboo and Jenkins. This will really ensure that your code is constantly tested and the versions are up to date. And finally, there is one very nice tool that I'm also using in my current company, and this is the JFrog Xray. This is a security tool for container and image analysis. This solution allows you to scan any dependencies for security vulnerabilities and policy compliance. JFrog Xray proactively identifies security vulnerabilities that could potentially impact your environment. And the best thing is that it runs natively with the JFrog Artifactory, which is, trust me, one of the most popular artifact tools used by many organizations. So let's look at some tools that can actually perform static vulnerability analysis in the Docker images. Tools like Clair, Dagda, and Anchor. So first, let's talk about Clair security scanning. Now, Clair is an open source project for static vulnerability analysis in container-based applications. Normally, layers can be shared among many containers, so it's important to create a package inventory and compare it with the known issues or the CVEs. So this tool provides vulnerability analysis service that works with API that analyzes each container layer looking for existing vulnerabilities. The tool can actually generate a report, a list of known vulnerabilities that are currently existing in your container. It basically extracts all layers of the image and notifies the user for the vulnerabilities that were found. Another quite useful tool is the Dagda. This is also an open source tool, but in that situation, the developers chose to use Python to perform the static analysis of known vulnerabilities in the Docker images and containers. It also helps you to monitor running Docker containers and to detect anomalies. So Datga retrieves information about the software installed in your Docker image, such as operating system packages, libraries, dependencies, and modules, and matches them against bigger database which stored all the vulnerabilities. This database is created from the collecting vulnerability data, and it is normally a database made from MongoDB, ExploitDB, basically a database that stores static data analysis scans performed on the Docker images. You can definitely feel free to check out the project on github.com, and you can see the link below. You can see right here the basic framework or the scheme of Datga. It normally has distributions for Red Hat Linux, CentOS, Debian, Ubuntu, and Alpine, so you can pretty much use it on most of the famous Linux distributions. So Datga internally uses the OWASP dependency check to analyze the packages and the dependencies on many languages such as Java, Python, Node.js, and more. So let's talk a little bit more actually about the OWASP dependency check. Now the OWASP is an analysis tool that pretty much checks the dependencies into the Docker images. It normally performs scans about the POM XML and the manifest files into the Java projects, and in case you're using, for example, JavaScript, it would check the package.json file. So the next vulnerability tool I want to share with you is the Trivy, and it's again an open source tool that focuses on dependencies vulnerabilities in packages at the open source system level. And also it can check dependency files on many different languages. So with Trivy, you can get information for vulnerabilities for metadata such as library, vulnerability ID, or this is a vulnerability identifier, the severity of your vulnerability, and those could be critical between 9 and 10, high between 7 and 8.9, medium between 4 and 6.9, and low between 0.01 and 3.9. You also get the installed version, the fixes version, and finally the vulnerability description. So definitely feel free to check out Trivy and apply it to your images from the repository that you can see below. That said, thank you very much for watching that video, guys. This was our review for the vulnerability tools, and in the next video we will cover Clair and QA. Thanks for watching.